If you ever come across triangles being described as congruent, this means that they are mathematically identical to each other. All their sides are the same length as each other's, and their angles are the same as each other's. So for instance, just these two triangles here. This one has lengths 3 meters, 5 meters, and 7 meters. This triangle has lengths 3 meters, 5 meters, and 7 meters. Therefore, if they have all the same side lengths, they must also have all the same angles. Therefore, in every respect, they are identical triangles. Yes, they've been flipped, but they have all the same proportions. With this in mind, therefore, we can say they are congruent because they share a side, and a side. When proving if triangles are congruent, you need 3 pieces of evidence. So these don't have to be sides, it can also be angles as well, assuming that those have been measured. So let's just turn our attentions to maybe this triangle down here with ABC. And if we're told that ABC is isosceles, this meaning that 2 of the sides are going to be the same length and 2 of the angles are going to be the same size. The question probably specifies in this case that that's your A, B and your BC, so as indicated by those 2 little perpendicular lines, that means they're the same length, and therefore if it's these sides that are the same, these 2 angles are going to be the same. If we want to show therefore that ABD is the same as CBD, we can say, okay, well, angle BAD is equal to angle BCD, so that's an angle. We can say that they both have a 90 degrees, because if that's 90 degrees here down the middle, this is going to be 90 degrees. So that's another angle. And you can also say, because it's isosceles, that this length here is equal to this length here. So that's going to be a side. You could also actually, in this case, say that BD, because they both share BD, that's another side they have in common. You don't need 4, but yeah, 4th piece of evidence. Yeah, I mean, also specify D as the midpoint. That means that AD and DC are going to be the same length. That would be yes, no, sorry. As you can see, there's plenty of ways to find evidence in these kind of questions. You just need to pick out the 3 that you can justify. They can get a little bit more complicated though, if we just turn yet again to the right with this circle here. We've got a quadrilateral ABCD inside of a circle where line AC is the diameter, as indicated by the fact it's going through centre O. And we also have that there's a line going through BD which is perpendicular to that AC, indicated by this right angle symbol here. Now, where then B to the line AC is 1 meter and D to the line AC is 1 meter. If the question then wanted us to show that triangles ABC and ADC are congruent to each other, well, because they both share AC, that means they share a side that has to be the same length. From your circle theorems, if you want to go into that, if we have a triangle inside of a circle where all 3 corners touch the circumference and one side is the diameter, that means the other corner has to be a right angle. This is true for both of those triangles. Therefore, we can say that that's now an angle they have in common. But as for the last thing, there's no immediate proof without any further calculation that say BC is the same as CD or AD is the same as AB. So we're going to use the fact that this 1 meter here and 1 meter here are the same. Because they're not actually sides of the triangles ABC or ADC, we can't just immediately go to say that the sides are the same. However, we can say, because BD is cutting AC perpendicularly, they're sharing this side here, AC, that is to mean this A, B, and this point here is a right angle triangle. It's sharing this side here with AD, this right angle triangle here. And if that's sharing a side, and they both have this side the same, then we can say that this would equal this. AB would equal AD. And if AB equals AD, that's another side for the big triangles that they also have in common. Mostly though, yeah, you don't necessarily have to go that far. Usually most of it is rather intuitive or spelled out for you. You just have to show that you understand the relevance of the information. With that in mind, therefore, let's turn to this on the right for you to have a go on your own. We have this quadrilateral ABCD here, and we're going to say that this is specifically a rhombus. You may just want to make sure that you're happy on the properties of a rhombus first. E is 1/3 of AC, and that AF is 2/3 of AC. With this in mind, can you show that triangles AED and CFD are congruent? Pause the video and have a go for yourself, and then press play again when you're ready to compare. Alright, so if AE is 1/3 of the way along of AC, and AF is 2/3 of the way along, that means 1/3 of AC is left for FC itself. With that in mind then, this is going to be the same as this. AE is going to be the same as FC. They are each 1/3 of a way from their nearest corner on that same straight line. So they so far have a side that's the same. Next, because it's a rhombus not only are BC and AD parallel and AB and DC parallel, but they're also all the same length as each other. It's like a special kind of parallelogram, just as a square is a rectangle with all sides of the same length. A rhombus is a parallelogram where all sides are the same length. Therefore, AD is going to be the same length as DC. That's another side they have in common. And then finally, if you were to consider the entire triangle ACD, again, because AD and DC are the same length as each other, that would make this an isosceles triangle again, making this corner the same as this corner, because these were the same length as each other. So angle EAD and angle FCD are the same, so that's now an angle this there. You have 3 pieces of evidence. You have shown that they are congruent. If you're happy with that, let's have a go at an actual question from a paper. Here we have a triangle with small triangles within it, and as it specifies, LMNB is a parallelogram. So again, as before, that's saying that the top and the bottom line are going to be parallel to each other, and the left and the right line are parallel to each other. But unlike the rhombus from a second ago, they aren't necessarily all the same length. They can be two separate pairs of lengths. L is in the midpoint of AB, M is the midpoint of AC, and N is the midpoint of BC. It wants us to prove that ALM and MNC are congruent. So this triangle up here at the top and this triangle here at the bottom right. And you have to give a reason at each stage. So we can already say that if M is the midpoint of AC, then AM is going to equal MC. That's already a side that they have in common. But for the rest, here, LM, right now, we could say that that is the same as BN. Now, BN isn't actually on the triangle MNC, so it's not immediately useful to us. But just as how with M is the midpoint, we could say AM and MC were equal. If N is the midpoint of BC, then BN equals NC. Therefore, so LM equals BN, but that also equals NC. I'm just looking at these two being equal to each other. That's another side. And if you haven't guessed already, we can now actually use that for the other one as well. We can say that MN is going to be the same as LB because it's a parallelogram. LB isn't immediately on the triangle ALM, however, but we can say because L is the midpoint of AB, AL is going to equal LB, so it equals AL. That is a third side that they have in common. You have your 3 pieces of evidence. You have shown that they are congruent.